I had to look at this question for quite some time. I put a double star by it because I was thinking this can't be that difficult, but it just looks really difficult trying to work out what this is. And the key actually is that it's only asking us for the integer part. This thing here is going to be irrational. So what we need to do is not work out what the whole thing is, but kind of work out a range of values that it might be between. That is a lower and upper bound. So let's say the actual thing is equal to x. Now, what I see, first of all, is that x is necessarily going to be bigger than root 72. If I just truncated it here, because if I add these extra values, it's going to go beyond that. So x is beyond root 72. Now, root 72 is going to be bigger than the square number that's below it, which is root 64, which is 8. So I know that x is going to be bigger than 8. It's just, could it be, could it be 9, could it be 10, could it be 11? So that's why I need to think about a upper bound for it. And this takes the most thinking, because like, how can we work out an upper bound for that? If you've never seen this before, then it's going to be tough, because what we need to do is let y equal an infinite kind of, instead of truncating it, just keep it going. 72 plus root 72 plus root 72, and so on. Infinite. And you might think, oh, it's just going to be infinite itself. But because we're finding a square root and we're just adding on these extra square roots, they're going to become increasingly small. I mean, that's not obvious, but we can actually show it, to be honest. And here's the thing. This here is also the original expansion. Because it goes on forever, that thing there is y. And this is an idea used in continued fractions and this problem here and other things. It's worth becoming familiar with, sort of it's nested within itself as such. So that means we can write down y is equal to the square root of 72. And you might think I would have never have known to do that, but that's why it took me a little while, but I've remembered in the past I've seen an infinite expansion that I managed to do. So then I thought I might as well just go with it. And it all works out from here because we get y squared is equal to 72 plus y squared minus y minus 72 is equal to 0. So y minus 9, this factorizes very nicely. Y plus 8 is equal to 0. So this is clearly positive. I can reject the negative. Y is going to equal 9. And this y, because I've increased the amount, is definitely going to be bigger than my original truncated one, which is x. So what that means is that x is bigger than 8, but it must be smaller than 9. And therefore the integer part is definitely going to be 8, and the value of 50a is going to be 400, which is our answer. Okay, great question, tough question. Well done on your effort on it.